Finally, let's look at the break-even analysis as one method to determine location decisions. You need to know that the break-even analysis has a wide array of applications, and making location decisions is only one of them. So, how does it work? What is the break-even point? I hope you already discussed this in some other introductory courses to business. The break-even point, this is a very important concept. The break-even point is the amount of goods that a company has to sell so that its revenue is equal to the total cost. Revenue and total cost are equal. This is the amount of products that we need to sell that revenue equals total cost. So if we know the break-even point, then we know how much to sell in order to at least not make a loss, and how much to sell in order to make a profit. So for example, you are a car dealership. And then the break-even point would be the number of new cars that you need to sell in a month, so that you can cover all your costs with the revenue and that you do not make any profit. If you sell more than this, then your car dealership will make a profit. If you sell less cars, then you will create a loss. To make this a little bit more formal, let's have a look at formulas for the total cost and the total revenue. So by big Q, we refer to the number of units that we sell. And small p is the price of one unit. So the revenue is just multiplied the price by the number of products we sell. The total cost, on the other hand, also depends on the number of items that we sell, big Q times the cost. And small c denotes the variable cost. For example, if we sell cars, then this is the price that we pay to buy a car. And maybe it's also including some transportation costs, so that the new car can arrive at our showroom. And these costs, small c, they depend only on the number of products that we sell. When we sell a small number of cars, then we have a low variable cost. If we sell a high number of cars, then we have a high variable cost. On the other hand, we also have fixed cost, and fixed costs do not depend on the number of products we sell. For example, in the car dealership, this might be the rent for our showroom. We have to pay the rent every month, and it doesn't matter if we sell 0 cars at all or if we sell 200 cars. Although the salary of the employee can be considered as some kind of fixed cost, because they also do not directly impact, you have to pay them whether you sell cars or not. If the salary of your employees has some bonus component that depends on the number of sold cars, for example, you pay each employee some kind of special reward depending on the number of sold cars, then this would be part of the variable costs. But the monthly salary that does not depend on the sales volume has to be considered as fixed cost. So the costs, we have fixed cost, big F, we have variable cost, C times Q, and the revenue, small p times Q. And in order to find the break-even point, that is the value of Q, where the total cost equals the total revenue, we can perform the following calculation. We set the revenue equal the total cost. The revenue is P times Q. Total cost is big F plus our variable costs, and then we solve to Q. So we can bring the variable cost on the left side. So on the left side now we have all the variable components, and on the right side we have the fixed cost. we move big Q out of the parentheses and divide by the price minus the cost. So that means our break-even point, the quantity where we have zero profit, is big F divided by the difference between the price, the sales price, and the variable cost. And now we can apply this for a location. So for each location, we have to determine the fixed cost and the variable cost. Fixed cost could be, for example, rent. Variable costs could be related to transportation costs, maybe different prices for our labor. Important is that the variable cost depend on the number of products sold, and the fixed costs are independent of the number of products sold. Then we draw a graph and we make a drawing of these cost curves. As it only depends on Q, Q is our variable, all others are parameters, and Q is only to the power of 1, then the cost curves are always a straight line. And as you know, a straight line is always precisely defined by 2 points. And so we have to find, or we have to choose 2 values of Q that we can enter into the equation to draw the straight line. And one value that's always available to us is Q equals 0, that is, we sell nothing. This can be the first point that we draw, and the second point should depend on the context of the number of the quantity that we can sell. Yeah, for some cases it might be 100, in others it might be 100,000. So you need to choose this point depending on the appropriate context. You do this drawing for all the given locations. If you have 3 locations, then you have 3 cost curves, and you draw all cost curves into one graph, and then you see some ranges of output where one location is the best. Once you've done this, you can solve algebraically and identify the proper break-even point. Now let's have a look at an example to make it more clear to you.